Okay, so number 17. Perfect. All right, we're gonna go ahead and draw a picture first. So the rest of the problems in the packet that we're doing, starting with number 15 through 22, those could be angle side side, where it's the ambiguous case and you have to check for two triangles, but it could be angle angle side or angle side angle and just be the really straightforward ones that you just do one triangle, you don't worry about the second one. Okay, so it could be either. So what we're going to do is we're going to start by labeling the information they give us to figure out if it's a straightforward problem or if it's the ambiguous problem that's a pain in the angle side side. Okay? Get it? All right. So angle A and angle B are not given. Angle C is 91 degrees. Side C is 29. Side B is 7. So if we look at the information they gave us, what situation is this? Yeah, we have two sides and an angle that is not in between them. So what is that? Angle side side. Or you could say side side angle. Okay, so how many triangles should I be drawing? 2, because it could be 2. It doesn't have to be, but it could be. So what information should I use to start the problem? Yeah, so I'm going to use side C with angle C. So I'm going to say 29 divided by sine of 91 equals 7 over sine B. Okay, so I'm starting off with this information right here, 29 over sine 91, and then 7 over sine B. All right, and what do I do? Cross multiply. All right, so before you start plugging information in, what should you check about your calculator? Yeah, make sure it's in degrees. So if someone has cleared your calculator since yesterday, if you're using a school calculator and they cleared it before they put it back, or if you have a habit of clearing your calculator, then you need to check and make sure it's in degrees because your calculator's default is radians. So we're going to have to continuously check to make sure we're in degrees so we don't get these problems wrong. You use degree when you're younger because it makes more sense, like in your brain. Conceptually speaking, it makes more sense. Radians are much more common in advanced math. So after pre-calc, you stop using degrees completely. All of calculus is in radians. And so I think the reason that the default is in radians is because of that for those upper levels. All right, so let's go ahead and start typing stuff in. What should I type? So what do I multiply sine 91 by? 7. Okay, so 7 times sine 91 divided by what? Divided by 29. So this decimal equals sine B. That decimal equals sine B. And then how do I solve for B? Okay, so second sign, second answer. Hey, sure. Yeah. All right, so the angle that we just found, angle B, is 13.966. Huh? Oh, it's fine. These videos are okay to interrupt. It's more when I'm like making one of the ones that doesn't have the class in the background and I like want it to be nice. Yeah. All right, so 13.966. All right, and then how do I find angle B for the other triangle? Do what? 180 minus that answer I just got. All right, okay. So we're going to do 180 minus second answer. And we have 166.034. Did anyone catch the little oops that I just did? No, it wasn't a mathematical mistake. It was a thinking ahead mistake. Because we're solving these triangles, we're going to find. Not checking it yet. I should have stored it. Does that make sense? So I should have stored this answer before I moved on to the next one because I'm going to need it in a second. If you go back and store it now, you're going to store this one right here. So what do we see if we look at these two?
Can you highlight it and
So I'll address that in a second. Okay, so what do we notice about these two? 166 and 91? Yeah, bigger than 180, so definitely only one triangle here, right? Okay, the reason I should not go back up and highlight this and grab it and just let it store it is, do you see what it did with that decimal? It cut it off. So is that the exact answer? No. No. It depends on how many decimal places of accuracy you need. And the reason I'm being nitpicky is because math classes after this will get nitpicky. So if you were to take this number and multiply it by 2, that'd be fine. Your decimals would be fine. But if you took this number and multiplied it by 5 million, then you rounded it 5 million times. And then your answer is really far off. Does that make sense? So the reason that we're storing our answers is because we want to learn in pre-calculus how to be accurate so that later on when it actually matters, we're comfortable with it and we're not learning it for the first time then. Does that make sense? I'm teaching you guys how to store your answers in situations that are a little bit easier to deal with. You feel like this is not a fun situation, but it's easier than the ones you'll experience later on. And so we're practicing it now, okay? So we need to go back and plug in what we did to get that 13.966 so that we can store that answer and have the perfect answer in there, okay? So what I'm gonna do is I'm just gonna go back up here and grab this so I don't have to type it again. And everyone's gonna have to do this unless you stored it. You just go up and press enter. So go up. So see how it's highlighted like that? Press enter. The reason I didn't teach you to do that with decimals is because I think it rounds them. All right. Okay, so we have that decimal. It's perfect. It's not rounded. All right, it's not rounded until I write it down. So what I'm going to do is I'm going to do sine inverse of that decimal. And then this I need to store before I go any further. You hit STO, so this right here, STO. So you're going to store it. What letter would you guys like to store it as? We could store it as B. It's angle B. Okay, so I'm going to hit store and then alpha B. So not knowing how to store numbers will probably not mess you up for pre-calc, but it's a good skill to have by the time you get to calculus, which is why I'm teaching it to you now, so that by the time you get there, it's no issue. All right, so I'm going to look right here. I'm going to say that angle B is 13.966 degrees. Oh, sorry, you couldn't see. All right, and we stored this as B, so I'm going to write that on my paper so I don't forget. And how do we continue the problem from there? Okay, so we're going to find angle A, right? We're going to do 180 minus 91 minus the number that we stored as B. So 180 minus 91 minus B. All right, so angle A is 75.034 degrees. And what should we store this one as? A, so I'm going to store it as A.
So after we finish the problem and like we clear calculator, does it work still kind of change?
In theory, if you clear your calculator, there should be nothing in there, but I don't know if it actually clears those numbers out or not. It might. We could check it, we could clear it and see what happens when we plug in A. All right, so I'm storing that as A, so now it's in my calculator. And on my paper, I'm going to write down that I stored it as A. So I have that this is 75.034. And what do I have to do to finish the problem? What do I have left to find? Side A. I need to find side A. Okay, so to find side A, what piece of information do I automatically start with again? It's circled in the problem. C. I start with C. So I've got 29 over sine 91. So anytime I'm solving for a variable from the problem, I'm going to go back to that information they gave me. And I'm looking for side A, and I'm dividing it by sine of what? Of angle A, right? Which is 75.034. Okay, and I can remind myself that's what I stored as A. All right, so what do I plug into my calculator? So 29 times sine of A divided by sine of 91. Okay, so I multiplied these two, and I'm dividing it by this one so that I can get that A by itself. Okay, do you guys need to see why I did that? Do I need to write that out, or are we okay with skipping that step? You okay? All right, so that means that side A is 28.021. And what's the units for that side? All right, kilometers. All right, so there's the three pieces of information that solve our triangle. Okay, so somebody remind me again how we knew there was not a second triangle. Yeah, the angles when we added them were too big. Okay, if we knew that this angle B was 13.966, how did we find that angle B? So this was the first one we found. How did we find the other one? We did 180 minus that first one. Okay, well, let's go ahead and try number 18, just make sure we're good. So again, we have triangle ABC. This is 19, angle B is 19, side A is 26, side B is 15. And so what situation is this? Angle side side, so what does that tell us? We need to draw two triangles and see if we have to keep both or just keep one. So how do we start it? We can find angle A. So what do we use to find angle A? We're going to use B. So we've got 15 over sine of 19 equals 26 over sine of A. Okay. So what should I type in my calculator? Okay. And we get a decimal. And what do we do with that decimal? Okay, so sine inverse of that decimal. All right, so we get 34.35. .355 actually, because we're going to do 3 decimal places. All right, and what should I do before I start typing other stuff? I should store it. Okay, so store it. What letter should we store it as? A. So if you did not clear your calculator, this is going to overwrite the A you used for the last problem. So it's okay. You don't have to clear your calculator between every problem. It automatically is overwriting it. All right. So I'm going to go ahead and typically what you're going to do anytime you're solving for two triangles is you're going to keep the information for the two triangles separate. So we're going to have one box of answers for the first triangle, one box of answers for the second triangle if it ends up happening that we have two. Okay, so let's go ahead and check first to see if there's two before we start writing down all these answers. Okay, so how do I find angle A for the second triangle? Okay, so I'm going to do 180 minus A. And I get 145.645. And what do we notice? It's going to work. Okay, do we see that? Yeah, I hate it when that happens too. All right, so it's going to work. So what does that mean? We got to store this, and we have to solve two triangles. Okay, so what do we want to store this as? You guys want to do B? We can't do AA. There's no AA. I don't think it works like that. You can try it, though, if you want to ruin your storing numbers. So we have to use a different letter. I don't think the double letters work, but I could be wrong. All right, let's go ahead and store it as P. So down here, I'm going to keep track of my letters. So I have angle A for the first triangle is 34.355. Angle A for the second triangle is 145.645. And I'm going to write that the first one I stored as A, and the second one we're going to go ahead and store as P. All right, so at this point, both triangles have side A and angle A, side B and angle B. So what are we looking for next? C. We need angle C. All right, so what can we do to get angle C in the first triangle? For angle C? We have two angles. We need the last one. Subtract it from 180. Okay, so we're going to do 180 minus 19 minus what we stored as angle A. All right, so that means that angle C is 126.645. And so down here I'm going to say angle C in this triangle is 126.645. And what do you guys want to store this one as? C? So when I do these myself, I typically use A, B, and C to represent the first triangle, and then I use completely different letters to represent the rest of the second triangle, so I'll use letters at the other end of the alphabet so I don't get confused. All right, that's just me. Some of you guys might be better at keeping track than I am. Okay, so we're storing that as C. Does everyone have it stored? Okay, so now we have all three angles, and we have side A and side B. We just need to get side C. And how do we get side C? We're going to use 15, and we're going to use sine 19. So I'm going to say 15 over sine 19 equals C over sine 126.645, which remember I stored as C. Okay, so one of the things that that we learn through doing math at this level is not just like how to do the math itself, because you guys are clearly learning some calculator skills right now. One of the big things that this lesson is going to teach you is how to keep track of information and follow the problem. Does that make sense? So you could try to memorize the steps to these problems, and that would be hard. These problems are easier to do if you just understand how to look for each thing. All right, does that make sense? So we have done the problem the same way every time. The steps are repetitive, but instead of memorizing this as a 15-step problem, it makes a lot more sense to say, oh, okay, so I missed an angle, so I needed to do 180 minus the other two, or I'm missing a side, so I set up the law of sines again. It's a little bit easier to think of it that way, because then you have two things to think about instead of 15 steps to memorize, okay? NCFE? Yeah, they wouldn't say anything like, it wouldn't say something like use the law of sines necessarily. It'd probably give you a triangle and say, what's this side? And you'd have to recognize like which law you could use. We're going to learn law of cosines today. So they might say like, what's the longest side? What's the biggest angle? Whatever. And you would have to know like, oh, that's a law of sines question. Yeah. All right. So what do we do to finish this part of the problem? Cross multiply. So we're going to do 15 times sine of what we stored as c divided by what? Sine 19. All right, and so side C for the first triangle is I said side C of the first triangle is instead of 15. Sorry. Let me go fix that. 36.967. And then what are the units? Kilometers, because it's a side length. Okay, so there we solved the first triangle. And then now we have to do the work to solve the second triangle. So the second triangle has angle A and side A, angle B and side B. We need angle C and side C. So how can I find angle C? So 180 minus 19 minus 145.645, which I stored in my calculator as P. So minus P. So we're going to say that that third angle is 15.355. And what letter do you guys want to store that as? Did you say D? Okay, so store as D. Okay. And then what do we need to solve for? We have all three angles, we have these two sides. So we need C. And how do we solve for C? (15 / sine of 19) equals C 15.355, which we stored in our calculator as D. Okay, so now we're going to go ahead and cross multiply, right? So we have 15 sine of 15.355, which is D, divided by sine of 19. And so side C in the other triangle is 12.200 kilometers. And so we have each of the triangles solved separately. So two sets of information. Okay. How do we feel about doing the ones that have the ambiguous case? It's a lot. It is a lot, okay? So if you can keep track of how the problems are organized, how to find each type of thing, you don't have to memorize the whole process all at once. You can just understand how to find each step. That's a lot easier, okay? So the plan for right now is you guys are going to finish the packet through number 22. When you flip the page, I scanned some story problems for you to try, And you're going to do 3 of them. One of them is number 29. You're going to do number 29. You're going to do number 31. And you're going to do number 33. Now, the nice thing about the story problems is they are typically not angle side side. They are typically angle angle side or angle side angle, because in a story problem, you typically have one situation with a picture that makes sense. I made sure to give you problems with pictures, okay? So when you do these ones, these are going to be more straightforward law of sines problems because the information they give you can only form one triangle typically, not 2. All right, does that make sense? All right, if they give you one that is angle side side, then you're going to have to try both triangles and see which one they're talking about. Okay, so I will make sure to have an answer here ready for that when you guys get there. All right, any questions with what you're working on? Okay, so go ahead and get started on that. All right, real quick, I want to show you something. Remember yesterday how I said in the ambiguous case, it was possible for there to be no triangles? You guys remember that? And then I told you that you'll see when it happens, like if we look at number 10, we knew that there were no triangles for number 10 because when we tried to type it in, we got an error message. Do you guys remember that? Okay, so in all the years I've taught, I've always seen the error message as the way to get no triangles, but yesterday, one of my students came up and they showed me that for number 11, you do not get an error message, but you find that the first angle is 157, the second angle is 23.717, and if you add 157 and 23.717, without an error message, you get that that triangle has 180.717 degrees for 2 angles. Does that technically work? No. Okay, so this is one where there is no error message, but technically there is no triangles. So that means that I was wrong. I've been wrong for 10 years as I've taught this. I've just not seen that before. So this situation is not common, but it does happen. Okay, and that would be any time these angles are very, very close to 180, you should check it. So we know that there's 2 situations where you could have 0 triangles. One for sure is you get an error message. That's very common. Okay. The other situation where there's no triangles is when you have angles and you have to look at them and say like, oh, that's really close to 180. Let me add my decimals and just make sure it's not. All right. In this case, it was too big. The same thing happens on number 21. Okay. So when you get down, put a mark next to 21, flag it. So that when you get to 21, you recognize that. The same thing's going to happen. You do not get an error message, but your angles are too big to make sense for the problem. So it tells you that there's 0 triangles. Any questions on that? I do not anticipate giving you one like this on the test because I feel like that's a trick question. All right. The ones that are more common, again, are the ones where they give you the actual error message. That's pretty common. This, again, not very common, and I just happen to find these because I have a worksheet generator. So I didn't pick these on purpose. They just happen to show up, but you don't see this very often. Okay? Make sense? Yes? Okay.